we can get started. Like I said, very pleased to share this information with the architectural community. Real excited to be part of that community and be able to communicate with you. If you have questions as we go about the webinar, in the chat box, just feel free to ask questions, and we'll be able to answer them as we can. We'll try to hold. At the very end, we'll have a Q&A for at least 10 or 15 minutes or so. But if you have specific questions, I'll try to get those as we go along. Feel free to put them in the chat box. I want to introduce you to Paul Hickson and Jaron Pugh. They are the founders and principals of HELIUS Lighting. At HELIUS, we've been around for 10 years, since 2002, and our focus are mainly on architectural lighting design, as well as lighting control and programming, and as well as motorized shades. We do some EE as well as AV design. I will let Paul and Jaron introduce themselves and kind of a bit of their background.
Okay.
Jaron?
Can you hear me over the me, or is it there we go. Hi, this is Jaron Pugh, one of the principals here at HELIUS Lighting, and to forego some of the background stuff, make sure you guys can. There's a lot of.
Hey, Jaron, I guess people are saying they can't hear you.
How about now?
So it looks like we're having some audio difficulties with Jaron. Let me see.
How about now?
Still nothing.
Hello? Hello?
Still nothing. Let me see if I need to unmute you on my.
How about now?
There we go. Now we can.
Okay. Sorry, guys. All right. Let's go back to the presentation. All right. Awesome. Don't know where we are. Okay. Paul and Jaron, we're the two principals of HELIUS Lighting Group, and to forego a little bit on the background of us, let me just say we've been in business since 2012. We've been heavily active in architectural lighting design, a lot of high-end residential lighting design, commercial when more creative solutions are required than just generally lighting a desk space, and definitely been heavily involved in a lot of hospitality and entertainment category type of lighting design. And today we're going to jump through a bunch of information in about an hour, so I'm going to quickly jump into that. And we're going to go through some of the technical aspects of light first. Some of the things that we want to talk about are bullet pointed here, so you can see what we're going to go through for the next few minutes. And one of the things about light is line, shape, color, texture, mass. These are design elements that you all use every day, that you use it with every project. You use it at the beginning of the project, you use it in the middle of the project. It's a standard design element that is used as you create spaces for individuals and for businesses. And light often comes into the design process a little bit too late in the process. Sometimes not even until they're getting ready to pull the wire and things like that is it time to start thinking about lighting. And we're here today to kind of stress that lighting is a crucial element of design that should be established early on in the design process. One of the quotes we like to talk about is how proper illumination at the bottom of the screen, it creates depth and at the same time can be rejuvenating and soothing to the soul in the places where we need them the most in our homes. And I would also add to any of our living environments, really. Lighting can create a key element of comfort, for wayfinding, for all of those kind of things. And so it needs to be an integral part of your architectural design, especially if you want to get the best outcome at the end. It's one of those items there where the finished product really is determined by what you do during the rough-in stage. You're not going to cover that up at the end with some creative solution. You have to get the lights in the right place with the right source in order to have it work and function the way that you want it to. All right, there's two groups of designers that are often classified when it comes to lighting design, and these two groups kind of fall into the scientific category or the artistic category. And the first one are the scientific, and these are people that often focus on light's scientific and measurable properties. In other words, how much light is coming out of a fixture, how much light is reflecting off of a surface. These are things that are generally focused on when we're trying to get an even amount of illumination across a desk plane, for example. If you're working in an open office, you know, the recommendation is often that we receive 30-foot candles, and we'll talk about foot candles in a minute in that open office space. But is that really what the space calls for or not? And that's where the second type of designer comes into play, and that's those that focus on the light's visual properties, such as glare, contrast, sparkle, beam spread, intensity. All of these things are parts of the visual aspects of light, and are things that need to be balanced with that scientific focus to make sure that, yes, we get the right amount of light in the right places, but how are we doing that? You know, are we looking at a whole bunch of glary fixtures across the ceiling plane that are actually detracting our eye from the objects that we want to look at, or that are detracting us from having a good experience in that space because everything is floodlighted and there's no depth created at all? So that's kind of the challenge as we create lighting design, is to effectively combine all of light's scientific and measurable properties into a medium of art and into an effective design as well. Okay, the science of light. We're going to spend a few minutes here. I'm going to talk really quickly to go through some of the technical goober concepts that, as lighting designers, we sit and consider as we create our designs. As architects, when you're working in your space, these are terms you certainly want to be familiar with, and if you're doing your own design, you want to become very comfortable with them so that you are specifying the products that you need to get the right results, and that you're thinking about the way those products are going to interact with one another. So let's move down to CRI with the first one. This is a term that many people have heard, refers to the color rendering index, and as it says, it indicates the ability of a light source to produce natural colors in an object. What that means is, CRI means that when you see an apple and it's red, it's the right red, that it's not, you know, some dull brown red that might be generated by a light source that generates the wrong color. So the CRI is measured on the CRI is measured in a scale from 0 to 100, and what's been kind of established over time is that 100 is basically the light that we see underneath an incandescent light bulb. There's a lot of technical stuff behind it, but in a nutshell, that's how that number was determined. So that when we see, so an incandescent light bulb, for example, has a CRI of 100, and so does halogen. When you get to other sources such as fluorescent, LED, things like that that we'll talk about, they have a variable CRI. Color temperature, this is measured in Kelvin and describes the color introduced into an area by the light source. So many of you have probably seen things specified on fixture packages where it might describe something as coming in at a 2700 Kelvin, or a 4100 Kelvin, or a 6000 Kelvin. So 2700 Kelvin is warm. That's the warm color that comes from an incandescent light bulb. You know, 6000 and above is a Kelvin color that we experience outside. And then there's a variable range inside there. 4100 Kelvin is a cool white color that a lot of us grew up with in going to school. Lumens is a measure of the total amount of light emitted by a light source. So how much light is actually coming off of a light source? This has become a critical factor as we've had the development of LEDs. Foot candles is the measurement of lumens following on an area measured in square feet. So as it says there, 1 foot candle equals 1 lumen on 1 square foot of space. So how much light is actually being reflected onto a desk surface? How much light is actually hitting the wall? Contrast, the difference between the brightness of an object and its background. It's fairly self-explanatory, but it's important to consider when you're thinking about the objects that you're going to light. For example, if you want to light a piece of art on the wall, you may need to light that typically if you really want that piece of art to pop off the wall, it needs to be about 5 times as bright as its surrounding area. So, you know, if the wall is receiving 5-foot candles, then you want 25-foot candles on your piece of art. Things like that. Those are things you have to consider. Beam spread is the angle of the beam, and I'm not going to read that technical thing right there. Basically, it's how wide is the beam that comes off of that light bulb. Is it a 10-degree beam, which is really narrow and focused? Is it a 35 or a 40-degree beam, which is the most common kind of beam spread with most of like our MR16 or our PAR 20 lamps? That beam spread can make a big difference in the amount of intensity that is seen on the objects that we're lighting. So, for example, if you want to use a small aperture from a 20-foot ceiling and still light objects below, you might want to go down to a 25 or a 15 or a 10-degree beam spread in order to get the light traveling that far without having to put a large 6 or 7-inch diameter can into the ceiling. All right, we're going to talk quickly about each of the light sources. Incandescent, we're all familiar with incandescent. It's what we've all been living with all of our lives. Its strong suits is its color. 2700 Kelvin gives us the candle glow that we are all comfortable with in our homes, that we're all comfortable with in any kind of an intimate, subdued environment. Has a great CRI, so when we see things under an incandescent light bulb, it has the color we expect to see. Your greens will look like the green we're expecting to see, reds will look red, those kind of things. The downside of our incandescent light sources is that it has gone, you know, the lamp life is short. You know, it's going to range anywhere from 750 to 3,000 hours. When we talk about hours, if you were to take like around a 2,000 or 2,500 hours, that's, you know, around 1.5 years of use in a normal home. Halogen sources are similar to incandescent in a lot of ways. They still have that high CRI of 100. Color temperatures are still going to be warm. They're going to be a little cooler. You've seen that when you use a halogen source where it starts out at that bright white and then as you dim it, it moves down to yellow. We can also get them in variable hours depending on the product that's specified. The longest lives we've ever seen are around 10,000 hours. Most commonly, you're going to see around a 4,000 to 5,000 hour range out of a halogen light bulb. They are really easy to dim, which is a great part of both incandescent and halogen, is that when you want to create some kind of a mood, you want to be able to have variable intensity. They are the most effective products at dimming. Great for accents, flood, ambient lighting. Still a great source today, even though so many sources are focusing on LED. Fluorescent light sources, they still have their place. We still use them a lot, especially in utility spaces. They do a great job especially for the price point of lighting large areas and providing a lot of general utility lighting into a space. So the CRI, that color rendering index that indicates, you know, how well a color looks, how well an object looks underneath that, that's variable with a fluorescent. So you want to make sure you pick the right light bulb. When you're going to specify a fluorescent fixture, it's one thing to specify a fixture that you think looks killer and whose form fits well into the space, but the next step in that is making sure that the light bulb that is selected is actually going to perform the way you want it to, so that if you want it to introduce a cooler color because it's an industrial space, that you specify that color accordingly. If you want it to be warmer because, you know, it's maybe in a medical application and it's in a waiting room and you want people to feel a little more comfortable as they enter, you want to pay attention to that CRI. Color temperature is the same way. It can be specified very warm, 3,000 Kelvin. It can be specified very cold, 5,000 Kelvin or more. So depending on the application will depend on how warm or cold you want that to look. Hours for your fluorescents are all the way up to 40,000 hours, which gets really close to our LED lamp life. So they can be a really effective light source, especially for the dollar. They're still a fairly inexpensive solution. Really efficient as far as the number of lumens delivered per watt. High intensity discharge, I'll go quickly over this one. This product is really quickly being replaced by our LED products. You may have heard of mercury vapor that burns kind of green. You may have seen high and low pressure sodium, which tend to burn yellow, and low pressure sodium even almost brown. Metal halide tends to burn white. They do require a lot of hardware to make them work properly. You really typically do not dim this kind of product. Its CRI is similar to fluorescent in that you specify it along with the color temperature to try to get the results you want. It is a really efficient light source, has been used for a lot of warehouses, gymnasiums, roadways, things like that over the years, but is quickly being replaced by LED, as many people have probably seen as they drive down the road and we see all the glare coming off of LED light sources outside. That's kind of something the manufacturers are going to have to figure out over time. Fiber optic light sources, just a quick word on fiber optics. Really, it's the same light sources that we already talked about. Halogen, LED, HID, all of these light sources are what are used with fiber optics. The benefit of the fiber optic is that the light source itself is remotely mounted. So you want to use fiber optics in a lot of applications where you're not going to be able to access the light source for maintenance. So you're going to put this light source in a remote closet, and then you're going to feed it over a fiber optic cable, like you can see in the bottom right corner of your screen, and that's going to feed out to, say, backlight, a stone wall, or it's going to go into a submersible application, or it's going to go into a star field in a theater, or perhaps it's putting behind a water wall where you're not going to have access to things like that. Those are great applications for a fiber optic source, as well as any room that you really want to make sure has no heat. If you want to keep the heat out of the space, all the heat stays back with the light source in the closet while the light travels across the cable into the space. And LED, the big elephant in the room, the one that everybody is really concerned about, and that quite frankly is changing the way all of us live and work in our spaces. The bullet point up there that you're not cool if you don't buy, sell, or specify LED is kind of true. If you're not knowledgeable about the LED, then you want to be, because your clients are going to have questions about it. Some of them are going to demand it, even though they may not understand why it should be used or shouldn't be used. If you've been hesitant to use the LED, now's a good time to start to embrace it. I would not say that you need to say that it is the only source to use on a project, but it is another solution for your projects. Even if you're most comfortable with halogen or incandescent light sources, LED is still a viable solution and needs to be looked at as another source within your design scopes, even if it isn't the only one. Some of the benefits of this that you've probably already experienced is its small size just really allows us to get light into niches where it was difficult before. In order to get the color right, we use lenses and coatings in order to overcome some of the difficulties generated by the LED product. It's low voltage, which requires a driver. Sometimes that's built into the product, sometimes it's remote mounted, which can be a source of labor cost. Its CRI is variable, so that color rendering index, the ability of that light to make a red look red, a blue look blue, is variable and specifiable, but it also can be inconsistent. So one of the things we recommend you often do when you're going to specify an LED product, especially one you've not used before, is get a sample or 3 of it so that you can see how that manufacturer produces its product, and that as it goes across the product line, you get consistency in performance, so they don't have 2 recessed cans right next to each other producing a different quality of color. Its color temperature is variable and consistent, or inconsistent. So, for example, you specify the warmness, the 2700 Kelvin that might be similar to an incandescent, or you specify the coolness, the 4100 Kelvin, that's going to be similar to a cool white fluorescent lamp. And you're going to pick that in the specification. But again, you want to see samples of that project to make sure that one manufacturer's 2700 Kelvin stays consistent across their own product line, and especially as you mix manufacturers within a space, that you get the same color that you want out of each area. So that's something to consider. The lamp hours on LEDs are going to range anywhere from 20,000 to 100,000 hours. Most are showing effectiveness at about 50,000 hours, and what that means is that at 50,000 hours they maintain about 70% of their original light output. So while you're not going to see the LED light go out, you're going to lose light output at a significant level at about that 50,000 hours. So you have to be careful about what's going on with maintenance there, and make sure that maintenance staff know that they need to keep track of when these went into operation. You can dim it. The dimming is tricky with LED, to say the least. You a lot of times will start to dim it. When you go from 100 to 80%, you might not see a whole lot of results. Between the 80 and 50% mark, you'll start to see significant dimming. And then a lot of times when you move below that 50% mark down to 20%, you may still see some good dimming. By the time you get to 20, you might also start to see flickering. It really depends on the product. And so if you're going to plan to dim with LED, it is critical that you vet the product and are comfortable with the way that that's going to work. And you need to make sure that your clients are comfortable with the LED product as well, because it is going to feel very different in their space than what they might have been used to. If it's in a residential application, the LED is a digital product, and so it burns digitally, where your halogen and your incandescent product are more like a candle glow effect of burn, where your LED source is more like having the TV on. So digital light versus candle light, and they do feel different. So as much as you can, we need to vet and qualify those kind of items with our clients, as well as to consider the additional cost that results from specifying LED products. They can cost, you know, as little as 30% more than the same product in a halogen source. Okay, we're going to move into technique, and I'm going to turn the time over to Paul to go through some technique and a lot of cool image shots.
All right, technique. In this little section, we'll just go over some really cool before and afters that you may have seen before. We'll also go over some techniques that we use as lighting professionals, kind of help define spaces. The biggest thing that's about light that's unique is that we need it to get around, we need it to see, but how do you use it as an art form? How do you use it to bring out the best of your architecture, and when? How do you light a sitting room differently from a dining room, differently from a laundry room, differently from a kitchen, differently from a den, differently from a bedroom? How do we go about space to space to space? The common practice nowadays is let's use recessed cans everywhere. As recessed cans developed, people went from 7-inch apertures to 6-inch apertures to, wow, we got 5-inch apertures now, we got 4-inch apertures, and a lot of clients are fine with the lighting design as long as it just has 4-inch downlights. Now we've got 3-inch, 2-inch, and some manufacturers are even pushing 1-inch downlights. But where to use them and why is the question. If every object, as it says, in a room receives the same quality of light, there is no emotion or mood brought into that space. So rather than just fill the room with light, just to say we have light to get around, how do we use the light and what kind of light, as Jaron went through with all the different lamp options, do we use? As it says on the bottom, one of my favorite quotes, proper lighting techniques should stimulate emotions, create atmosphere, and enhance feelings. You should be able to walk into a space and know what that space utility is for. Am I in the sitting room to sit, to contemplate, to read, or am I in this sitting room with big glaring lights to gather with friends and socialize? You know, how is the space illuminated? So going back to, going on to some before and afters, figured out how to use a cursor so we can kind of point around a bit. Here we have a standard family room, dining room with a lot of layers of light. You'll see recessed 2-inch pinholes as downlights that are lighting furniture, lighting coffee tables, lighting art, lighting textures on the wall, and then we have a chandelier over the dining table. The only difference between the before and afters is in the after. All the other layers are the same, but in the after we have the 2 pinhole downlights that have some blue lensed light to shine into the crystal chandelier. So you can see the drama that's brought in just by adding 1 layer of light into the space, taking that opportunity. Here we have an exercise on recessed housing selection. Pretty typical what you see. 6-inch eyeballs back from the 70s. You know, we're in the year 2015. Probably shouldn't see much eyeballs, but actually manufacturers still sell them. Here those eyeballs are replaced with 4-inch downlights to graze down the architecture, the wood wall. You can see the texture of the wood really pops here, and when you walk into this space, you're actually noticing the architecture more than you're noticing the light source. Our eyes are naturally drawn to the brightest spot in the room. This, you hope, is the architecture and not the light source itself. Before and after on layering. This is a good lesson on layering. So we have a really ornate dining room with an ornate chandelier. Typical practice. We're just going to hang a chandelier because it's our decorative piece. It's what everybody wants to see. We're going to turn it on as bright as we can because we need all that light from those bare lamps exposed so we can see what's going on in the space. Here we actually use the layers that were intended, so we have downlights to wash the cabinetry, the drapery, and we have pinholes over the table that are actually getting more light onto the table than the chandelier itself. And we're able to dim the chandelier and torchères at a lower, more comfortable level so we can experience the space better. Here's a good lesson on trim selection again. And here we have just 6-inch downlights. These are actually before LED really took off, so these are 100-watt A-lamp. Incandescent downlights. Here we just use the same lamp, same housing, replace the trim with the regress wall wash so that we kick more of the light up onto the vertical plane and just does a better job of getting light into the cabinetry. It doesn't create the big cove here. And all that we did was just replace the trim. Little tricky now to do with the advent of LED. Trying to find a good regressed wall wash in LED is a little difficult because LED by nature is a point source, but still there are options there. Application shots, these are just single image shots where we'll just show quickly the applications we had for opportunities in the space. Here we have a master bedroom. Worked with the architect to understand there were some Corinthian columns that would be gold leafed here. So rather than fill the room with a ton of light, we wanted to create the drama, do some art lighting on the wall, create some pathway around the perimeter. There's some reading lights over the bed, and then really bring the punch and the focus onto the architectural elements of the columns there, rather than just plop in lights in the space. Worked really well for the client. Another one is this exercise room. When we walked into this space, we knew as big as the home gym would be, we did not want to just put recess cans everywhere. We also didn't have a lot of ceiling height to do a lot of indirect and other things in the ceilings. Plus, the homeowner wanted to kind of jazz up their space a bit. So knowing that this line right here was all mechanical drop, we worked with the architect to see if we could balance that in the space, create a false drop here, and found 120 volt line voltage indirect light source cable system that kind of played in the space. We get a ton of light out of these indirect sources and complemented them on the walls with, you can kind of see that, some wall sconces that kind of played with the cable system. Would not have got enough light using your standard low voltage cable system. Took some research to find this European line, but it kind of worked, and you have plenty of light comfortably to lay down on a bench and get your work out. Here we've got another opportunity where originally this fireplace was designed with wall sconces flanking a piece of art. As we were doing a job walkthrough and they were laying this limestone, we noticed that the art had been changed to a honed etched section in the center. No more art on the wall, so we took the wall sconces, took that lighting load, and had the electrician do a linear source to graze up the stone. Not the best quality picture, but that's the intent here, is to actually take the opportunity to understand the architecture and make changes in the field if you need to. Next is a fun exercise on collaborating with third parties. Here, the pool guy had it in their package to design their own lights, and we had to work with them on helping them understand that this is not just a pool, it's an experience. You walk into this pool, they had a big piece of art, they had this water feature. We didn't want the pool guy to throw a light here, a light here, a light here, a light here, so when you walk in, you're blasted by these lights. So we made sure they knew to put all their lights on this side shining in. We also knew that this space needed to be experienced not just as a pool, but as a place for gathering. So we wanted to set some scenes in here where the client could come in, press a button, and have this, I'm just going to sit in the hot tub, or I'm just going to read a book, do whatever. So we have 4 recesses above the pool that are just shining into the water feature themselves. And then we worked with the pool guy to make sure he understood that this one center light needed to be on its own circuit, so we could turn just that one on as the water cascades down into this pool of light, leave the rest of the lights in the pool off. When they're swimming, yes, they can turn the pool on and there's much more light. But right now for this, we had to work on collaborating where to fit the lights and how to switch them independently to create this scene. It's all about scenes.
Before you go on,
Yeah.
we got a question from Regina. She asked, and I think it was regarding not the slide you just showed, but the previous slide, if the pinholes were LED.
Here?
I think the previous slide.
Here?
Wherever you're talking about pinholes.
These pinholes?
I think so, yeah.
No. Nope. This project was done before LED.
Okay.
Are these uplights? No, they were not. They would be now. This product was probably 12, 13 years ago. Yeah, these were halogen light sources. That was actually an MR11 halogen 20-watt MR11 lamp.
Okay, and she's asking that as well. The cornice source, they're halogen.
Yeah.
They are.
Yep. Right now, I know GE and a couple offshore lines make MR11 LED retrofits, so I'm sure by now the client possibly would have changed to that. That is available right now. We would be specifying a native LED uplight for this, kind of testing it to make sure it would dim, but we would be going through the research probably first off to specify LED, mainly because we'd want to make sure that that light source was cool to the touch as well. But first option would be there. So
Thanks, Paul.
Yep. Back here, just another exercise on lighting a massive volume, even from this upper tier. We're 20 to 30 space or feet above, so we use linear lighting in all of the purlins and truss systems to shine up into the ceiling, and then recess just really tight 8-degree beam spreads to shine down onto the furniture. So using the right lamp, you still can throw light residentially long distances. You just have to plan for it accordingly. Next. This is a lesson on trim selection. So here the interior designer we worked with was pretty adamant that all the recessed lighting housings, again from a 30-foot throw, so we're able to go 30 feet from here down, that they blend into the ceiling. They wanted them painted to match the ceiling. A lot of labor was taken to take these recessed trims, paint them to match the grain of the ceiling. But when you turn the light on, this is what you see, all the glare from the paint. Here we have an exercise on a black Alzac trim. So yes, we do have a 3-inch black hole in the ceiling, but when you turn the light on, you don't look down the hallway and see bam, 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 light bombs. So just an option on trim selection. Had we had our druthers, I probably would have worked harder to work with the interior designer to put black Alzac in here. The black would have blended away with the wood, and we'd have more of this effect as well. But just trim selection is important too in the final product and the aesthetic. This is a fun one, really quick. Fluorescent lights in the cove to put off a lot of light into a gym. We didn't want to create more heat, just keep it nice and simple and clean. We asked for a gym layout. The project said that's not that important, don't worry about it, but we do want the ceiling fan. We have one already picked out, put it in the center of the room, so we did. It's about a $2,000 ceiling fan. They set up the gym, turned the light blade on, the fan started to wobble, and bam, hit that little wheel there, and they had to buy a new ceiling fan and move all their equipment. So furniture layout is really important, as Jaron will go over as we discuss information gathering in a minute. Unique, let's go back. Just looking for opportunities. We knew we had this great piece of art on this wall, and rather than throw light on the bridge for pathway plus another row really close to light the art, we used the back of the bridge with monopoints to wash up into the artwork. So just opportunities to light it differently than anticipated and keep the ceilings clean. And those were 2-inch flush downlights. Here's an exercise on what we had to go through to sell a concept to the client. They have this glass back wall in their bar downstairs. They wanted to backlight the glass, yet upon further review, it was understood that we did not have maintenance or the ability to take off the glass and maintain the light source from behind. We had to use fiber optic lighting to do this. And so we had to do a rendering and a mock-up. Well, first off, a rendering to sell them on the idea of what it would actually look like, where we would lose light, where we would gain light, how it would be affected by the acrylic glass or the glass that was on the wall. Also explain to them This lighting system could cost, fiber optic system on this wall will cost about $7,000 to $8,000 to do properly. Are you okay with this before you spend the money? And we just kind of guess. From that image, they said yes, and we got the final product. And let's see. Another one on just technique. We have this great ceiling structure that kind of cantilevered out. We used a light source on the outside as well as the inside, creating a cove on the inside so that we have this light band going through the space from the interior to the exterior. Really not as stark in person. We had to really play with the exposure, so that's why it's so bright here, but the idea is showing the opportunity to light up a room from a soffit line both on the interior and the exterior. And last, I think last, pretty close to last, is concepts of reading lights. So here we have an 18-foot high ceiling above, general lighting lamps, pathway down light. We have two recessed reading lights you can't see that are lighting the bed. This kind of takes you through the concepts of scene control and what different scenes can do. Turn all the lights off. This person can sleep while can read while the other sleeps. And lastly, don't be afraid to introduce color into your space. An environment of a spa and a gym, we're able to just have some fun with that. A client that was willing to do that. So, and now back onto the process of how we get from A to Z. Those were the techniques and the applications, but how do we actually get there? So, Jaron will fill you in.
Okay, guys, so the process for executing an effective lighting design is really similar to the process of effecting an effective architectural design. And for us, we feel like it really should mimic that process and hopefully start as early as possible in the process. This should be a part of your earliest stages of design, and then in order to make sure it's executed properly, it will need to follow through all the way to the end of the project. So you can kind of see the bullet points here, and these are probably a process that many of you work through every day in your normal workflow. Information gathering. One thing as you consider your lighting design that you're going to create into a space is what are you going to light, really? And that's where the information gathering comes into play. We need to know, a lot of times we'll have clients that will send us either just floor plans or they'll send us just a reflected ceiling plan and tell us to light it. And then we follow up with a whole lot of questions to try to find out everything that we can about the space. So the floor plan and the reflected ceiling plan are really important. And as far as reflected ceiling plan, when we refer to that, we want to know where the changes in ceiling are going to happen, you know, or where details in the ceiling might happen and what the finishes of that ceiling might be. And then we'll work with you on where what your lighting placement is going to be and things like that. So the other things that are going to affect all of that is going to be your furniture plan, your cabinet details and elevations, art locations, areas of priority. In other words, you know, a lot of times, especially when you're working through budgets, clients will say, you know what, this is the showpiece of my home, or this is the lobby of my building, and I really want to make these things special. But when it comes to a secondary bedroom, or it comes to a back of house kitchen or storage space, those areas are like, you know what, let's keep that inexpensive and things like that. We need to talk to clients about what those priorities are so we can focus on that in design. Design themes, you know, is this going to be a subdued, is this going to be an accent-oriented space, or is this going to be, do we want this brightly lit like a football field? You know, I mean, what is the overriding theme the client is communicating to you, and what do you want to pull off inside your space? Are there architectural opportunities like some of the ones Paul showed you in those details? You know, does it make sense to do uplighting to light the bottoms of a column? Are there beams? Is there a really cool wood ceiling that deserves some attention? You know, all of those kind of things need to be considered as you start the first phases of your design. Colors, finishes, reflectance properties, energy codes, lighting restrictions, all of those things need to be considered as we start the design process so that we can establish budgets early on in a logical manner, in a way that can be vetted and qualified. one of the things I would stress to you, architects, as you work with builders and things like that on early budgets, is if you don't know what has been spent on a successful lighting project that you've been happy with, is to get some sort of lighting professional involved to give you an estimate of costs. If you do not get an estimate of an overall cost for the building, chances are you're going to be going through some sort of a VE process, because once it's lit properly, it's usually going to cost more than what most people think it's going to cost for a high performance product, especially now that things have changed to LED, and following the end of the recession, most lighting manufacturers raised their prices substantially, and so a lot of budgets are still too low in order to be effective. Okay, schematic design. When we present a schematic design to a client, and what we recommend that most people do when they do this, present this to a client, is just go through a simple placement pattern. So as you can see in the bottom left corner of the screen, you know, take your recessed cans, take your decorative pieces, take your switched outlets, your linear things, take all of those design elements and go and put them on paper. If you need to do it through chicken scratch because of schedule, that still can be worthwhile. But take those things and put them on paper so that you can have a discussion with the client about the design direction that you're heading, where you're looking for art walls, where you're looking for accent, where you think niches are important. You may discover where their priorities are that they weren't able to mention before you started the schematic design, because then they'll have something to comment on. What you'll find most of the time is that most clients have very strong feelings about their lighting, but they have a really hard time commenting on a blank piece of paper. So if you can go through the schematic design process, this will really start to move your lighting design forward in a logical manner that'll actually accelerate the process and have less changes as you continue to move through. We also want to consider fixture specification as we go through this early part of the design process. This could be assembled in a simple cut sheet binder without actually establishing a full specification at that time, while we're still figuring out what the client wants and what they're willing to pay for. But all of these elements on the right, these are elements that need to be considered as you go through your fixture specification. What is a light source going to be? You know, is this a client that's an early adopter that's going to want an LED source throughout their house? Or is this a client that's a little old school and wants that candle glow effect? You know, is this a client that's just going to want a whole lot of light everywhere, and so we're okay spending less money and flooding the space with a fluorescent light source? Those are things to consider. Desired light distribution pattern, you know, again, is it going to be flood? Is it going to be accent? That'll help you determine what you're going to select as a product. You know, illuminance level, so your foot candles, you know, do you need to dim in this space? How important is control of your light source in this area? For example, you know, in a theater, it's really important that you can control that dimming level down to 0, but in your kitchen, it may only be important that you can dim it to 50%. So maybe you're going to use halogen in a theater and LED in the kitchen, things like that. Desired level of direction control, glare control accessories. You know, like Paul talked about in some of those examples, if we can avoid seeing the lamp, if we can avoid seeing the light source, and if we can avoid seeing glare on the top of those fixtures, we want to. The aesthetic finish, mechanicals construction, how solid is that manufacturer? How solid is the stuff that they make? Thermal and acoustic characteristics, maintenance characteristics, efficiencies, especially when it comes to codes, we really have to consider lumens per watt. A lot of times we have to maintain a 1 watt per foot average as we go across a commercial space, and so you need to know what kind of efficiency you're going to create by that selection. Product reliability and availability, you know, is this a product that can ship in 2 weeks, or is this a product that requires 4 months? And what's the pace of the project? What time frame do you have for ordering and getting ready for rough-in? Safety and life cycle costs, all of these are items to consider. All right, then you're going to move into design development. This is often termed a permit set by a lot of people. We feel like this is the area where you really try to establish a meaningful design set that can be priced. So at this point, you've gathered information in order to execute your design. You've gone through a schematic design exercise and a review with the client. or with yourselves internally to determine whether your design is headed in the right direction, whether everybody's comfortable with it. Now we're going to actually add wiring to this thing. We're going to, you can see on the bottom right of your screen how we've got these little purple lines running from light to light and things like that. So you're going to establish your switching pattern and things like that. You're going to consider which loads do you want coming on together. So if you're lighting down a gallery hallway, you know, you might have one layer for some pathway lights that are only going to come on at 50%, and then you have another layer for art lighting that's going to come on at 80 or 90% in order to really make that art pop off the wall. So these kind of things are considered at this stage of design. When you release this set of prints, you want to be able to issue this to contractors so that they can price this set and then send it back to you with budgets so that they can be compared to the early budgets that were established in the schematic design phase and find out if you're on target. And this is a time where we can then present that information to the client and find out if we're on target, and if we are off target, you know, what trade-offs are they willing to make? What trade-offs are we willing to make as a team in order to get dollars within budgets and be able to move forward in the creation of a construction document set. If you're careful about your design development set, then hopefully by the time you've reached the construction document set, all of the cost implications have been decided, everything's been vetted, and we can just tell the construction team to go ahead and work. There won't be any need to go through a VE process with the construction team because you'll proactively have gone through that process, and then you can just tell them to go to work, and you won't be beholden to the construction schedule. As we all know, once a construction team gets a hold of the plans and they start moving, there's not a whole lot of wiggle room in schedule. You have to keep those guys moving. So you want to take care of this in-house as part of your design as much as possible. Construction documents. This is where you button up that DD set. Anything that came out of budgets, budget results, anything that's changed in the architecture and the floor plans and the furniture plans and art and client priorities, all of that stuff gets wrapped into this construction document set, which means we are ready to go. We're going to go ahead and execute this lighting plan, and we will make the small revisions that are needed, but we are going to create all of the details and things that are needed for you to go to work, order your material, and get going. In the process of a CD set, you're going to bring all those things together. You're going to add your dimensioned reflected ceiling plan. You're going to add construction detailing. For example, when they look at a recessed can in the ceiling, the construction team is going to know what that means. But when it comes to an under cabinet lighting and you're forming some sort of a L-shaped bracket underneath there so that you can light the back wall of the kitchen backsplash without getting a whole lot of bling bling from the LED nodes down into the counter surface, they may not understand exactly how those details need to come together. So we want to add this construction detailing at this point. You finalize your specifications to make sure everything that you're specifying is within budget and that finishes are selected and all of those kind of things so that the construction team can just get to work. At this point, if it has not been, if you're using a third-party consultant and it has not been integrated, this needs to be integrated into the architectural set. One of the reasons for this is so that the construction team pays as much attention to the lighting plan as they need to. If it's a part of the architectural set, then they will treat it as an important document for all parties of the construction team to pay attention to. If you release it as a separate document, a lot of times you're going to see that the electrician looks at it, but that the builder, that the millwork companies, that any other plumbing, framing, all of those people don't pay any attention to it. But if it's integrated as part of your architectural set, then everybody's responsible for those. We distribute that to the construction team. They know if there needs to be some preliminary meetings in order to explain how things work and what the design intent is, then that's what you do. But bringing all that together as part of your architectural set is a key element. So we go through creating these CDs. There's a lot of budget implications that happen. These are just kind of giving some ballpark dollar estimates on materials and where they can range. So knowing what the project's budget priorities are is important as you create your specification to make sure that you're choosing products that are within budget. Construction administration, we're going to wrap up here, but construction administration, you're familiar with this. This is what you do every day. This is where you come on site. You make sure that all the things that you dreamed up in the design process can actually be executed. And where you're going to run into trouble, this is where you're going to advise the construction team on what should happen in order to get the best result. I'm not sure it's always the best idea to let your electrician make those changes in the field as he runs along. Their priorities may be different than yours, and you may want to oversee that process. All right, that's it. That wraps up our presentation on lighting design and how to execute an effective lighting plan. We've got about, I guess about 9 minutes, 7 or 8 minutes left in our time frame here. But as we close, I want to say thank you for attending our webinar. We're really glad that you came. We hope you've gleaned some useful information. All of our emails are listed there for you. Feel free to email any of us with questions that you have, any advice that you might need. We're happy to help. If you'd like to see a sample set of drawings or a sample or a PDF version or paper, send an email off to Kevin and he can get that to you. If you're interested in any kind of services that we can help you with, we'd be happy to. And we'd like to spend a few minutes answering a few questions, I guess, that have come along the way. We
do have quite a few questions that we'd like to get to. But before we get to that, I just want to maybe virtual round of applause to Paul and Jaron for spending the time and sharing this information with us. I've gotten quite a few comments over GoToWebinar how much you guys appreciate this information. Want to let you know that we'll want to do these every quarter. In the next 2 or 3 months, we'll be having another one of these. So be on the lookout. And also want to let you know that I've received quite a few of your AIA numbers, and some of you are not affiliated with AIA yet still need to get CE credit for your state certificates. I will be sending out a certification. Just send me an email letting me know that you need that. And again, my email is listed there on the screen at k.elzey@heliuslighting.com. Also, I want to reiterate what Jaron said. If you want sample drawings of the presentation as well as sample drawings of kind of the work that we do within the we can send you PDF versions of those. Also, if you're interested in having us come out and do either a lunch and learn or a virtual lunch and learn, we're more than welcome to share that with you. Let your friends that are sitting in the cubicle next to you that we'll be putting this presentation up on our website within the week, and people can come and watch this and get CE credit for that as well. They'll have to take a quick quiz at the end that will ask them specific questions to make sure that they actually did listen and learn from this, but it shouldn't be too difficult. But I want to provide that service to the architectural community to get them learn about lighting, architectural lighting design, and then be able to fulfill their CE credits. For those of you who came late, I need to remind you that I still need to get your AIA member number. Either email it to me or put it in the questions, and I'll be able to submit those to AIA so that you can get credit for this webinar. Let's jump into the questions, and we've got about 5 minutes left. I think Jaron and Paul have agreed to stay on for another 10 or 15 minutes afterwards, as long as we need to. One question that was asked by Glenn, they asked about LED light in a greenhouse. Paul, do you want to take that one, or Jaron?
Sure. Can you hear me okay from here? Good.
Yeah, I probably scooted in. There you go.
Never really had the opportunity of lighting a greenhouse before, but I know in greenhouses, essentially, you're dealing with full spectrums of light. You're dealing with different things, whereas, plants and trees and shrubs and stuff want a different type of light than your fruits and vegetables that also want a different type of light than your seedlings and stuff. Philips, and from the websites that I've seen and the research that we've done, Philips probably has the best information and products specifically for LED greenhouse lighting. There's a lot of offshoot manufacturers. You can go online and just Google LED greenhouse lighting and buy whatever you want. But Philips actually has a great resource to understand their product that is specific for what you're growing. And we can probably send you that email or if we have your email, we'll just send you the link to that website. And that's probably
I'll send the link.
it's really good website.
Another question that we've had is someone asked, they've never used a lighting designer before. What's the difference between using a lighting designer versus an electric engineer or electrical contractor? One of you guys want to touch on those different relationships?
Sure. Certainly a lighting designer, when you hire a lighting designer, they're focused 100% on lighting. Most electrical engineers will consider themselves lighting designers. We would tend to find most electrical engineers, and you may find one you really like that does a good job with lighting. We find most electrical engineers approach things from the scientific standpoint, where they really focus on kind of generally lighting a space and arriving at an even illumination point. Not so much worried about color and depth and texture and all of those kind of things. It's going to be a very code-driven kind of even illumination kind of feel is what you're going to find from your electrical engineer. So in that way, that's where probably the difference in personality comes between a lighting designer and electrical engineer. And with your electrical contractors, you can find some that are creative, but their set of priorities is going to be a little different from that of a design team. So the electrical contractor is going to want to specify products for you that are the easiest for him to source and the quickest for his guys to install. And that isn't necessarily a bad thing, depending on the priorities of your project, but it also may not reach the aesthetic or the performance level that you're after. He's going to have his own agenda. So in order to make his company successful in contracting, not necessarily successful in helping you execute design. So really it's just the mentality of the people that you're hiring as consultants when you select them. So it doesn't mean that the other two solutions are necessarily the wrong solution, but you need to consider the space that you're lighting and what you want to try to achieve when you make a selection of that consultant.
That's great. Thanks, Jerry. We got a question, and some of them are real specific to a project that you may have. Blake, you asked about cost per square foot for upgrading a hotel lobby in a 5-star hotel, and we've had other questions who asked very specific to specific projects. If you would like, you can reach out to Jaron and Paul, and they'll be more than happy to give you some guidance on that. And if it makes sense for us to do the work, we can. If it doesn't, then we can just give you some consulting time or really whatever.
Well, and honestly, just to say thank you for coming to the webinar. If you can send us a little additional information, we'll try to provide some free advice as best we can.
Yeah, absolutely.
Well. So
yeah, absolutely.
We appreciate you coming.
Yeah. Someone asked about LEDs. They have a better control on brightness. Are retro bulbs a good transition in old incandescent fixtures?
Sure. You know what? LED retro bulbs, that's a market that continues to grow like wildfire. I mean, there is an unbelievable amount of LED retrofit bulbs. Paul and I just attended the largest lighting conference in North America that happens each year. We just attended it in New York last week, and there's a never-ending sea of retrofit LED bulbs. The one manufacturer we've been most successful with is Sora Lamps, S-O-R-R-A. I believe it's 2 R's.
2 A's, S-O-R-A-A.
S-O-R-A-A. That's the manufacturer we've found to be the best as far as color rendering, ease of use, maintaining the form factor of the lamp. A lot of manufacturers will create a MR16 light bulb, and it'll burn and even have good color and have reasonable dimmability, and then you try to put it inside of a track head or some sort of an application, and it has a little extra lens on top of it, so all of a sudden it doesn't fit. So anyway, that's been a source that we've used. We have found and recommended to a number of residential clients that maybe they use a halogen product to let their price point be where they need to from a budget standpoint, and then they can change the the light bulb out to an LED light bulb at any time whenever they want to. What's the trade-off often between using an onboard LED product and a retrofit lamp is going to be one of life. So you're going to go from like a 50,000-hour light bulb down to a 25,000-hour light bulb. You're also may make a few trade-offs in your dimmability and things like that. And but you may also save around 20% in your cost structure and things like that. And we have a white paper we have that talks about especially residentially, what's the difference between LED and halogen, and our recommended practices for that we can send to any of you as well.
Mm-hmm. Well, and the other option to that is it doesn't lock you into a certain manufacturer's current day technology. I mean, manufacturers today, even the good LED recess manufacturers, are coming out with version 2 in 6 months and version 3 the next month. I mean, it's continually upgrades and changes, and now it does this and that. So that's just the frustration of where we currently are. They're so much better today than they were 8 months ago, and they'll be so much better in 8 months than they are today. So it's how do you navigate what's the best option for you.
We got a great question in, coming back to the previous question of lighting designer versus the electrical engineer, from Sanjeev, who asks, when you hire a lighting designer and an electrical engineer, who should be the one signing off on the energy code?
Typically, the lighting designer should prepare that document. At least we think they should. I mean, it depends on the capability of your lighting designer. If your lighting designer has the ability to enter the information in ComCheck and go through the energy analysis and sign it off, then they should. It's just going to save a step in the process if they handle it in-house. If there's some lighting designers you may hire that might be uncomfortable with that because they're a little more on the frou-frou side of design, and they just want to think creatively and not have to be subject to codes. In that case, you may have to have that lighting designer really coordinate closely and proactively with the electrical engineer so that the electrical engineer has time to respond in order to give advice back to the lighting designer to say, well, you're out of compliance here, so what do you want to do about that? That'll create a little additional layer of coordination.
One of the someone brought it to our attention, and I'm sad we didn't catch this. Kevin's email address on the back slide is incorrect. It's k.lz at HELIUS Lighting. So we're missing a dot between the K and the LZ. So we apologize for that. So it's k.elzey at HELIUS Lighting. So thank you for bringing that to our attention.
Any others we want to go through?
Yeah,
one question there's one question about can I still use halogen incandescent? Why are we hearing it's discontinued? That's a common question that we've heard, and just to try to clear the air for some of you on that is you can still get halogen and incandescent light sources. What the government did in their restrictions is basically put new requirements on the manufacturer requiring a certain lumen output per watt, and it made a lot of the existing products of a few years ago obsolete. So they couldn't manufacture that. So now when you used to see something at 100 watts, it's now a 72-watt light bulb. When you saw a 50-watt bulb, it's now a 40-watt light bulb or a 38-watt light bulb, that kind of thing. So you can still get them. The manufacturers are not spending nearly the R&D dollars on halogen and an incandescent light bulb as they are on LED. I mean, almost all of their dollars are going into LED, and so you can still get those. You just have to be a little more careful about the way you specify them, and have to do a little additional research into finding, the resources to specify them.
One question that we have was, and Paul, you saw this. The questions about the strategies we use to comply with the requirements of 2012 International Residential Codes Energy Efficiency Chapter.
The trick with that is when it comes to lighting and energy efficiency codes residentially, it's all predicated upon the utility of the space and how the different states want to govern the different regulations. For instance, California obviously has Title 24. More states are adopting something similar. In fact, most are now. But it's all driven by, again, your lamp that you're using on your lumen per watt. So if you have, I think, a 5-watt lamp, you're allowed, or no less than, anything under a 5-watt lamp, you're allowed no less than, I think it's like 60 lumens per watt. And it goes all the way up to, there's a bracket and a tier system up to 40 watts. If your lamp is 40 watts, it has to be 90 lumen per watt. The challenge with that is not all lamp manufacturers are rating their lumen per watts. In fact, most of your point source lights in your halogen family, your MR16s, your PAR 20s, your PAR 30s that we've been using for years don't even have a lumen per watt or a lumen listing, because lumen is you know, it's a number given on a lamp in energy in all directions and not in a single specific direction, whereas those lamps are using candle power. So you can get one light that's taking 50 watts of light, putting it in one direction, but it has a broader beam pattern, so its candle power is less than if it were in a 10-degree spot. So it's kind of tricky navigating that. We haven't had to deal much with tight regulation other than Title 24, so we kind of stick to what Title 24 offers. Latest was 2013, I think, and now they're coming out with an updated 2016 version, and so we kind of try to stay around that, knowing that the way energy codes go in California, they'll probably shift east, and we just design more around that as far as the strategy goes. So it's tricky, but it's what it is, and there really isn't a strategy other than say this is what's required, so we design around that.
And I didn't know, I'm trying to remember when I read the 2012 IRC, I reviewed that not long ago for some other stuff, and I don't remember a whole lot specifically regarding lighting efficiency. There are some other efficiencies in there, but I don't remember a whole lot specifically related to lighting on that. I'd have to review that a little further for you.
Yep.
Is that it, Kev?
One last question. William Lamica asks, he says, Clay, you might want to come look at this. I'm not sure if I can.
Yeah, he just essentially just listed the tiered. It's funny because the code says specific requirements, how much high efficiency lighting you can offer, and then it doesn't really state what high efficiency is, and you have to go back to your bracketing and your state to understand what is a high efficient light source. In the old days, 5, 6, 7 years ago, it was more of your high efficiency lighting has to balance your inefficient lighting. So you could throw as much wasteless energy in a space as you wanted as long as your inefficient lighting was balanced by high efficiency lighting. At least now they're putting in regulations on 75% of your total lighting has to be high efficient. And then you just have to revert to, well, what is my state and what is my local code saying for what is high efficiency? What is my lumen per watt on this lamp for what the wattage is for that lamp? It's a 40-watt lamp. It's got to be 90 lumens per watt. If it's a 30-watt lamp, it's got to be 65 lumens per watt. And you kind of have to regulate that to determine how to better light your space.